Imagine looking up at the night sky and seeing not one moon, but nine. Nine glowing worlds, each moving across the heavens in its own unique path, filling the darkness with an incredible celestial dance. At first, it might seem like the most beautiful sight imaginable. But beneath that breathtaking view lies a reality that would completely transform life on Earth. Oceans would behave differently, the skies would never look the same, and even the stability of our planet could be pushed to its limits. What if Earth had 9 moons? Could humanity survive, or would our world become unrecognizable? Our single moon plays a much greater role than most people realize. It stabilizes Earth's tilt, creates the tides that shape coastlines, and has quietly influenced life for billions of years. Now, imagine multiplying that influence by 9. Each moon would have its own size, orbit, and gravitational pull. Instead of one predictable tidal cycle, Earth would experience overlapping gravitational forces pulling the oceans in multiple directions at once. Some coastlines could face enormous tides every day, while others might see the sea mysteriously retreat for long periods before returning with tremendous force. Ports, cities, and entire ecosystems would constantly struggle to adapt. The night sky would become a spectacular, yet chaotic masterpiece. Sometimes several moons would appear together, casting brilliant silver light across the landscape. On other nights, giant moons could eclipse one another, creating breathtaking patterns that no human civilization has ever witnessed. Darkness would become rare. Many animals that depend on nighttime darkness for hunting, migration, or reproduction would have to evolve entirely new behaviors. Creatures guided by moonlight would suddenly face a sky that never followed a predictable rhythm. The gravitational interactions between 9 moons would also affect Earth's rotation, tiny changes occurring over thousands or even millions of years. But there is another possibility that cannot be ignored. 9 moons orbiting Earth would constantly pull on one another. Their gravity would slowly change their paths over time. Some moons could drift into dangerous resonances, where repeated gravitational interactions gradually destabilize their orbits. Eventually, one moon might collide with another, breaking apart into thousands of fragments. Those fragments could create spectacular rings around Earth or trigger devastating meteor storms as debris enter the atmosphere. A peaceful night sky could suddenly become a source of global danger. Space exploration would also become far more challenging. Spacecraft leaving Earth would need to navigate through a constantly changing network of gravitational forces. Missions would require incredibly precise calculations to avoid close encounters with multiple moons. On the other hand, astronauts would have many new destinations for exploration, each moon offering different landscapes, minerals, and scientific discoveries. Humanity's expansion into space might accelerate because nearby worlds would always be within reach. Life itself might evolve differently under these conditions. Coastal ecosystems would adapt to unusual tidal patterns. Plants could synchronize their growth with multiple lunar cycles instead of just one. Animals might develop completely new migration routes based on the positions of different moons. Human culture, mythology, and religion would almost certainly revolve around these 9 celestial companions, giving each one its own meaning, stories, and traditions passed down through generations. Whether Earth could truly support 9 stable moons depends entirely on their sizes, distances, and orbital arrangements. In carefully balanced conditions, such a system might survive for millions of years. But in most realistic scenarios, gravitational instability would eventually create collisions, orbital shifts, or moons escaping into space. Extreme tidal chaos on Earth. With 9 moons, their combined gravitational pull would create unpredictable and extreme tides, constantly reshaping coastlines and affecting oceans worldwide. If Earth had 9 moons, the first and most immediate transformation would be seen in the oceans, where gravity would no longer follow a simple and predictable pattern. Instead of a single dominant lunar influence shaping tides twice a day, There would be multiple competing gravitational pulls acting on Earth's water at the same time. Each moon, depending on its size and distance, would create its own tidal bulge, and these bulges would not align neatly. They would overlap, clash, and sometimes cancel each other out, creating a world where the sea is never calm in a predictable rhythm. In such a system, coastal regions would experience extreme and irregular tidal behavior. One day, a coastline might face unusually high tides that push water far inland, flooding areas that were previously safe for settlement. On another day, the same region might experience unusually low tides, exposing vast stretches of seabed that are normally underwater. This inconsistency would make coastal life extremely unstable. Cities near oceans would struggle to maintain infrastructure because sea levels would not behave in a consistent cycle. Harbors could become unusable without constant redesign, as docking points might be underwater one week and stranded above water the next. The gravitational interaction of 9 moons would also create what can be described as tidal interference. Just like waves in water can overlap and form larger or smaller waves, depending on their alignment, the gravitational forces of multiple moons would interfere with each other. At times, when several moons align on the same side of Earth, their combined pull would create massive tidal surges. These surges could result in powerful flooding events, reshaping shorelines, eroding land, and depositing sediments far inland. On the other hand, when the moons are positioned in opposing directions, their gravitational pulls might partially cancel each other out. This could lead to unusually weak tides, where ocean levels remain relatively flat compared to normal expectations. While this might sound harmless, such inconsistency would disrupt marine ecosystems that rely on predictable tidal cycles. Many species of fish, crustaceans, and coastal plants depend on regular changes in water levels for feeding, breeding, and survival. A disrupted tidal rhythm would force these species to adapt quickly or face extinction in certain regions. Another important consequence will be the constant reshaping of coastlines. Over time, the repeated cycle of extreme high tides followed by unusual low tides would accelerate erosion in some areas while building new land in others. Beaches might disappear in one decade and reappear in another location entirely. River deltas could shift unpredictably, altering freshwater systems and affecting agriculture. Entire ecosystems that depend on stable coastal environments would be forced into continuous migration. Human civilization would face enormous challenges in adapting to such a dynamic ocean system. Early settlements would likely avoid coastal regions entirely or build structures far inland to reduce risk. However, modern economies rely heavily on ports, shipping routes, and coastal trade centers. In a 9-moon Earth, maintaining global trade would require constant monitoring of lunar positions and tidal forecasts that are far more complex than anything we currently experience. Engineering solutions like massive sea walls might offer temporary protection, but even these would struggle against unpredictable multi-moon tidal surges. Fishing industries would also be deeply affected. Fish populations would migrate in response to changing water depths and currents, making traditional fishing grounds unreliable. Night sky would become constantly bright and complex. Multiple moons would make nights much brighter, with frequent lunar alignments, eclipses, and overlapping shadows creating a dramatic and ever-changing sky. If Earth suddenly had 9 moons, the night sky would transform into a constantly shifting cosmic display that no human civilization has ever experienced. Instead of a single familiar moon guiding the rhythm of nights, there would be multiple lunar bodies moving independently across the sky, each with its own orbit, brightness, and speed. Some would appear large and dominant, while others would look like distant, glowing spheres. On certain nights, several moons could be visible at the same time, arranged in breathtaking patterns that change from hour to hour. The sky would no longer be a stable canvas, but a dynamic and unpredictable stage of celestial motion. This constant variation in the sky would dramatically affect how humans and animals perceive time. The traditional concept of a month, which is based on the single moon cycle, would no longer exist in a simple form. Instead, multiple overlapping lunar cycles would create confusion in tracking time. Ancient calendars would struggle to form, and modern timekeeping systems would need to rely entirely on artificial measurement rather than natural cycles. Civilizations might develop complex astronomical systems to track each moon separately, assigning different meanings and symbolic importance to each one. The brightness of a night would also change dramatically. With 9 moons reflecting sunlight toward Earth at different times, nights would often be far brighter than they are today. In some situations, overlapping full moons could illuminate the surface almost like daylight, reducing the natural contrast between day and night. This would have a profound effect on ecosystems. Many nocturnal animals depend on darkness for hunting, protection, and navigation. Under constant or frequent lunar brightness, Earth's climate and stability could be disrupted. The gravitational influence of multiple moons could affect Earth's axial stability, potentially changing seasons, climate patterns, and long-term weather systems. If Earth had 9 moons, one of the most serious and far-reaching consequences would be the effect on the planet's long-term stability. Today, Earth's single moon plays a critical role in stabilizing the tilt of our planet's axis. This tilt is what gives us seasons, and its stability ensures that climate patterns remain relatively predictable over thousands of years. With 9 moons exerting gravitational influence from different angles and distances, that delicate balance could become far more complex. Instead of one steady stabilizing force, Earth would be pulled in multiple directions, and even small shifts in those forces could gradually build into large-scale changes over long periods of time. One possible outcome would be a slowly changing axial tilt. If the moon's gravitational forces interacted in unstable ways, Earth's tilt could begin to wobble more significantly than it does today. Even a few degrees of variation could dramatically alter global climates. Regions that are currently temperate could become much hotter or colder over time. Rainfall patterns could shift, turning fertile agricultural lands into dry deserts or transforming dry regions into flood-prone zones. These changes would not happen overnight, but over centuries, they would reshape the geography of human civilization and natural ecosystems alike. Another major impact would be on the length of Earth's day. The gravitational pull of a single moon is already slowly slowing Earth's rotation over extremely long timescales. With 9 moons, this effect could become more complex. Depending on their orbits, some moons might increase tidal friction more than others, creating uneven and unpredictable changes in rotational speed. Over millions of years, this could slightly lengthen or even